I want you to close your eyes for a second, assuming you aren't driving right now, of course.
Definitely keep your eyes open if you're driving.
Right. But if you can, just imagine sitting in the cockpit of an early 20th century aircraft. You're surrounded by this fragile web of fabric stretched over a skeleton of metal tubing.
And the exposure to the elements is just absolute.
Completely absolute. You have the slipstream howling around your goggles. There is a deafening roar of a rotary engine firing literally right in front of your face.
Spraying castor oil right back onto your flight suit.
Yeah, exactly. Castor oil in your face, and you are operating at altitudes where the cold just penetrates your bones. Now, add the primary complication to all of this. You are in the middle of a major conflict, and your objective is to aim a machine gun at another aircraft.
Which brings up the core engineering paradox of the whole era.
It really does.
Yeah.
Because to hit a target directly ahead of you, in a tractor configuration aircraft, you have to fire straight through the arc of your own spinning wooden propeller.
Right. You are literally tasked with bringing down an enemy without instantly turning your own propulsion system into flying splinters.
And the mechanical challenge of that era, it just cannot be overstated.
No, it can't. I mean, you're looking at a scenario where a single mistimed round doesn't just mean a missed target.
Right.
It results in catastrophic structural failure of your own aircraft mid-flight.
Welcome to the Deep Dive. I am so thrilled to have you with us today. If you are the kind of person who is fascinated by those singular, those technological pivot points in history, this conversation is custom-tailored for you.
It really is a fascinating turning point.
Today, we're immersing ourselves in a highly detailed set of historical encyclopedia excerpts. These documents detail the origins, the intense technical specifications, and the combat history of the Fokker Eindecker series.
And our mission today is to trace how one specific, seemingly mundane mechanical innovation completely altered the trajectory of aviation.
Exactly. We're examining that precise moment when aircraft transitioned from being these unarmed observation platforms into dedicated, lethal weapons systems, which, fundamentally shifted the balance of power during the First World War. Joining me to dissect this incredible mechanical and historical data is our resident expert.
I am very much looking forward to unpacking the granular details of this machine with you. What's fascinating here is the sheer scale of the paradigm shift the Eindecker represents.
It's massive.
It really is. Prior to this aircraft's deployment, military aviation doctrine was strictly relegated to reconnaissance and artillery spotting.
Right, they were essentially high-altitude cavalry scouts.
Precisely. The Eindecker forced a complete doctrinal rewrite. By successfully marrying a forward-firing weapon to the primary flight axis of the aircraft, it ceased to be a mere vehicle for an observer. It became an integrated weapon system.
Okay, let's unpack this, because to understand that shift, we have to look at the origins of the airframe itself. And the lineage of this legendary German fighter is, well, it's deeply intertwined with the aerospace designs of the very nations Germany was fighting against.
Yeah, it's a brilliant piece of historical convergence. We start with Anthony Fokker, a Dutch aviation pioneer, and his chief designer, Martin Kreutzer.
Right.
Now, the aircraft that would eventually become the Eindecker, which, by the way, simply translates to monoplane, was not originally conceived as a fighter.
No, its direct predecessor was the Fokker M5K.
Exactly. The M5K was an unarmed scout aircraft. It carried the military designation E.III.
And if you look at the aerodynamic profile of that M5K, it bears an uncanny resemblance to a pre-war French design.
Heavily influenced is probably an understatement. The source material is quite explicit about this. The underlying aerodynamic layout was based heavily on the French Morane-Saulnier Type H,
which was a very successful pre-war shoulder-wing monoplane.
It was. Fokker and his team utilized that proven French aerodynamic baseline. However, the crucial divergence, and really the first major innovation in this story, was the approach to material science and structural engineering.
Because the French were relying on traditional materials, right, like ash and spruce for the fuselage skeleton. So how did Fokker's team approach structural integrity differently?
Well, Fokker completely discarded the wooding fuselage structure used by Morane-Saulnier. Instead, he opted for a fuselage welded entirely from chrome-molybdenum steel tubing.
Chrome-moly steel.
Yes. And if we connect this to the broader evolution of aerospace engineering, this is a massive leap forward.
Because wood is tricky.
Very tricky. Wood, while light and workable, has wildly variable tolerances. It reacts to moisture, it splinters under ballistic impact, and its tensile strength is inconsistent.
Right, whereas chrome-molybdenum steel tubing provided an unprecedented level of rigidity and uniform structural durability.
Exactly.
I would imagine that welding chrome moly seal in a 1915 production environment presented its own set of intense manufacturing challenges.
Oh, without a doubt.
But the payoff in sheer survivability must have been immense.
Absolutely immense. The weight penalty of the steel was completely offset by the sheer resilience of the airframe. And this structural rigidity became absolutely vital later on.
When they started fighting.
Right. When these aircraft transitioned from gentle reconnaissance flights to violent, high-G dogfighting maneuvers, the steel tube fuselage could withstand aerodynamic stresses that might have easily compromised a wooden airframe.
Okay, so we have a Dutch engineer building a steel-reinforced version of a French monoplane for the German military.
That's the setup.
But an airframe alone doesn't make a fighter. The defining characteristic is the synchronization gear. And I was reading through the source text regarding how Fokker first demonstrated this synchronized parabellum machine gun. The logistics of that demonstration are almost comical.
You're referring to the events of May 23, 1915.
Yes. So the German High Command needs to see this revolutionary weapon system. And you would assume a project of this magnitude, something that could alter the entire air war, would be transported under massive operational security.
You'd think so. A covered train, perhaps?
Or a heavily guarded convoy flying at night. But no. Instead, Anthony Fokker personally towed the prototype aircraft behind his own civilian touring car to a military airfield near Berlin.
The juxtaposition of cutting-edge military technology and incredibly ad hoc logistics is just striking.
It's a bizarre image for you to picture. A luxury touring car bouncing down a dirt road in 1915, kicking up dust, with a tarp-covered, state-of-the-art fighter prototype hitched to the back.
It feels less like a synchronized military operation and more like a scrappy startup trying to get their prototype in front of investors at the last possible second.
Exactly. It really highlights how chaotic and improvisational the early days of military aviation were.
And that improvisational nature extended far beyond just the transportation. To truly grasp how experimental this technology was, we have to examine the specific aircraft that served as the primary test bed.
Right. Because the path from that towed prototype to a functional frontline fighter runs directly through an airframe famously known as the Green Machine.
The Green Machine. The source documentation on this specific airframe bearing the Fokker factory number 216 details an incredibly unorthodox service history.
It didn't start its life anywhere near a weapons testing facility.
No, it did not. This particular aircraft began as a standard unarmed A-series Scout, designated A.1615. Its pre-war history is what gives it that distinct moniker.
In 1913, it was purchased privately, right? By an Oberleutnant named Waldemar von Butler.
Yes, and von Butler had a very specific aesthetic in mind, stemming from his prior military service.
Because he had previously served in the Jaeger Regiment.
Precisely. And Jaeger regiments traditionally utilized green uniforms, so he ordered the airplane to be painted a vibrant green to match his old unit's colors.
Which is wild. In an era where most aircraft were leaving factories in standard, clear-doped linen, this bright green monoplane must have been highly conspicuous.
It was essentially a flying billboard for his former regiment.
So the war breaks out in 1914. How does a privately owned Green Scout plane end up as the proving ground for the first synchronized machine gun?
Well, the German Air Service, the Fleeter Troop, essentially requisitioned the aircraft right alongside its owner when von Butler was commissioned into the Prussian army.
A package deal.
Exactly. But the critical handoff happens a few months later. In November 1914, von Butler found himself serving in a unit stationed in Belgium, and the unit operated under a rather fascinating cover name.
The Brieftaube Abteilung Ostende, or BAO.
The Ostend Carrier Pigeon Detachment.
A brilliant piece of wartime misdirection.
It really was. And serving alongside von Butler in this carrier pigeon unit was a pilot named Lieutenant Otto Parschau.
And the source strongly suggests that this deployment is where the two officers connected,
Yeah.
leading to Parschau eventually taking possession of the Green Machine.
Yes. Parschau became incredibly attached to it. He flew it extensively on both the Eastern and Western fronts during that first year of the war.
He even personalized it, painting LT Parschau on the right upper side of the fuselage, right behind the cockpit.
But the Green Machine's role shifted dramatically in late May of 1915. Parschau was stationed at Douai with Feldflieger Abteilung 62, and the Fokker factory engineers arrived to modify his personal scout plane.
This is the moment the Eindecker is truly born.
It is. The factory technicians fitted Parschau's A.1615 with the very first trial version of the Fokker Sturm synchronizer and a Parabellum MG-14 light machine gun.
The theoretical engineering is sound, right? Link the gun's firing mechanism to the engine so it only fires when the propeller blade is cleared.
In theory, yes.
But the practical application during those June 1915 combat trials sounds like an absolute nightmare for Parschau.
If we look at the historical reality of technological adoption, the first iteration rarely functions as designed under combat stress.
Right.
Parschau repeatedly maneuvered this newly armed prototype into firing positions against enemy aircraft throughout June, only to have the synchronization gear fail. The Parabellum machine gun persistently jammed.
The sheer frustration of that. Executing a perfect aerial intercept, committing to the attack run, pulling the trigger, and experiencing a mechanical failure. It must have been agonizing.
Beyond frustrating. And highly dangerous.
But while Parschau is dealing with jamming weapons, there is another highly specific, almost forensic engineering debate surrounding this particular aircraft that the source material highlights.
You're referring to the mystery of the wing root anchorage location.
Exactly. It's a fascinating detail about the aerodynamic evolution of the airframe. The original French Marin-Saulnier design and those early Fokker Scouts utilize a shoulder wing configuration.
Meaning the wings were attached high up near the top longerons of the fuselage.
Right. And Parschau's Green Machine originally had this high wing configuration. But the definitive production Eindeckers all featured a mid-fuselage wing mount.
Which is an important distinction. Lowering the wing root is not a trivial modification. It shifts the entire center of pressure, alters the center of gravity, and completely changes the aerodynamic profile and roll characteristics of the aircraft.
The historical debate centers on whether the Green Machine itself was ever modified to this mid-wing configuration.
Because there are rumors.
Yes, rumors that when the aircraft was sent back to the Fokker factory a second time, they lowered the wings. But the source text is definitive on this. Despite the rumors, there is absolutely no photographic evidence to prove that A.1615 ever received the lowered wing modification.
Furthermore, the first batch of 5 M.5 kmg production prototypes were still being built with the original shoulder wing design.
So the transition point in the design language is marked by a different airframe entirely.
Yes. Parschau was eventually issued a second Eindecker, designated E.115, carrying the factory number 191.
And that second aircraft provides the definitive proof of the engineering shift.
It does. While E.115 did not roll out of the factory with the mid-fuselage wings, photographic evidence confirms that it definitively received this unique, lowered wing modification while it was actively in service.
It just demonstrates how fluid the engineering process was. They were literally altering the fundamental aerodynamic geometry of frontline aircraft based on ongoing flight testing.
Tinkering with the planes between sorties, essentially.
Right, and while the aerodynamics were being tweaked, the Fokker engineering team back at the factory had to solve the lethal reliability issues of that jamming machine gun.
The transition from those early failing prototypes to the terrifyingly effective production models required a major mechanical overhaul of the synchronization gear.
Because those early trial versions of the Sturm gear, the ones that caused Parschau so much grief, they utilized a mechanical drive taken directly from the engine's oil pump drive shaft, correct?
That is correct. It was a complex linkage that proved far too fragile. And more importantly, it was prone to timing drift under the immense vibrational stress of a rotary engine.
So what was the mechanical breakthrough for the production EI models? How did they fix the drift?
The engineers abandoned the oil pump linkage entirely. For the definitive production version of the Sturm gear, they integrated a large cam wheel directly into the system.
A cam wheel?
Yes, and this is a crucial mechanical distinction. A cam wheel provides a direct, robust, and physically deterministic linkage to the engine's rotation.
So it can't slip out of phase.
Exactly. The timing of the interrupter gear was now immutably locked to the physical position of the propeller blades. The singular shift from a complex shaft drive to a robust cam mechanism is what transformed the Eindecker from a dangerous experiment into a highly reliable weapon of war.
The engineering underneath the cowl was becoming refined, but the source material details a highly specific aesthetic choice regarding the exposed metal on these early Eindeckers. It wasn't just raw steel.
No, it was quite ornate, actually. All the exposed sheet metal paneling, the engine cowls, the forward fuselage sections, and even the internal sheet metal components featured a very specific dragged engine turning finish.
Engine turning is usually associated with high-end horology or the dashboards of bespoke classic cars.
Right, that process of applying an abrasive tool to create overlapping, swirling geometric patterns in the metal.
The idea of a dragged version of this covering the nose of a combat aircraft is visually striking.
It really speaks to the pre-war craftsmanship traditions that were still lingering in the early days of military production. The factory artisans were applying decorative finishes to weapons of war.
It's hard to imagine that today.
It is. The source notes that this dragged appearance was also applied to the earliest Fokker biplane fighters, such as the DI. However, as the brutal reality of the war of attrition set in and the demand for mass production skyrocketed, this labor-intensive practice was completely abandoned by the end of 1916.
They sacrificed the aesthetic for pure output. Makes sense. But regardless of how beautiful that swirled metal looked on the tarmac, the reality of taking this machine into the air was terrifying.
Absolutely terrifying.
When you analyze the aerodynamic layout, specifically the tail section, it becomes apparent that the Eindecker was an incredibly hostile machine to pilot.
Hostile is an apt description. The flight characteristics were notoriously unforgiving, and this stemmed from a fundamental design choice. The aircraft possessed absolutely no fixed tail surfaces.
None at all. Let's delve into the aerodynamic implications of that. Standard aircraft design relies on a fixed vertical stabilizer, the fin, and a fixed horizontal stabilizer.
Right. Those fixed surfaces act like the fletching on an arrow. They inherently want to dampen oscillations and keep the aircraft tracking straight and level.
They provide innate aerodynamic stability. But the Eindecker discarded that entirely. Both the rudder and the elevator were fully all-moving surfaces.
They were entirely aerodynamically balanced. When a pilot moved the control stick, they weren't just deflecting a small trailing edge, they were pivoting the entire aerodynamic surface.
Which means the control response must have been incredibly violent.
The source explicitly states that the aircraft was hyper-responsive to pitch and yaw inputs. The slightest displacement of the controls resulted in massive, immediate changes to the aircraft's attitude.
So there was no inherent stability to mask or absorb sloppy piloting.
None. For a novice, simply maintaining level flight without inducing severe oscillations was a monumental task.
There is a brilliant quote in the text from German ace Lieutenant Kurt Wintgens that perfectly encapsulates this chaos.
Oh, I know the one.
Yeah, he was one of the primary pilots testing these armed monoplanes in the spring of 1915, and he described the experience by saying, "Lightning is a straight line compared with the barogram of the first solo."
It is a wonderfully evocative description, a barogram being the output of a barograph, tracing the aircraft's altitude over time.
For the altitude trace to look more erratic than a lightning bolt speaks volumes about the pitch instability.
You are constantly fighting the airframe just to keep it from violently pitching up into a stall or diving toward the ground.
And while the pitch and yaw were hypersensitive, the roll response was notoriously sluggish.
Because it relied on wing warping rather than modern ailerons?
Right, so you have a twitchy, unstable platform that fights you on every axis. And yet, the pilot workload gets even worse when you look at the engine management, specifically the fuel system.
The fuel management system is a stark reminder of the immense cognitive and physical load placed on early aviators.
Starting with the Fokker E.III variant, they repositioned the main fuel tank. They moved it behind the pilot.
But the rotary engine relied on a gravity-fed system.
So to get the fuel from the main tank located behind the cockpit up to the gravity tank so the engine could function,
The pilot had to manually pump it.
and this wasn't an occasional task. The pilot had to physically hand pump the fuel up to 8 times every single hour.
8 times an hour.
Just imagine the sheer terror of that multitasking for you as a pilot. You are in a life-or-death aerial engagement. You are wrestling with an aerodynamically unstable airframe that wants to throw you out of the sky if you stop paying attention for a second.
You are trying to manually aim your entire aircraft at an evasive target to utilize your fixed machine gun.
And amidst all of this, a timer is ticking in your head, reminding you that if you don't take a hand off the controls to physically pump fuel, your engine will starve, seize, and you will become a gliding target.
It truly shatters the romanticized image of the effortless night of the sky. These pilots were managing a complex, physically demanding, and highly unstable piece of machinery while simultaneously trying to invent the tactics of aerial combat from scratch.
It's unbelievable. And despite these massive pilot workload issues, the airframe was undeniably effective. It rapidly evolved. The Fokker factory continuously pushed to extract more performance out of the design, leading to a rapid succession of variants from the EI through the EIV.
The evolutionary path of the Eindecker is almost entirely dictated by the availability and integration of increasingly powerful rotary engines.
So let's look at the numbers. The initial production model, the Fokker EI, saw 68 units built.
Correct. And it was powered by a 7-cylinder Oberursel U.0 rotary engine, producing 80 horsepower.
But 80 horsepower in a combat environment quickly becomes insufficient as the enemy develops faster scout planes.
The demand for more speed and a higher climb rate led directly to the E.III.
And they built 49 of the E.III variants.
Yes. The primary upgrade was swapping the 80 horsepower engine for a 9-cylinder, 100 horsepower Oberursel UI.
But upgrading an early aircraft engine wasn't a simple modular swap.
Not at all. The 9-cylinder UI had a significantly larger physical diameter than the 7-cylinder U0.
And accommodating that larger diameter created a cascade of structural redesigns throughout the forward fuselage.
It did. Because the engine was wider, the engineers had to raise the upper nose paneling to align with the larger diameter cowl required to house the spinning cylinders.
Right, because the whole engine spins.
Exactly. And raising this paneling meant its outer edges now overhung the upper longerons of the fuselage. To resolve that, they had to extend the cowl even further back.
It was a complex, cascading series of structural modifications simply to house an extra 20 horsepower.
Which was a massive increase at the time.
True. With multiple variants requiring different structural configurations, the production lines must have been incredibly complicated. How did Fokker manage the manufacturing output?
The encyclopedia notes that it was a highly parallel and somewhat chaotic production environment. Production of the EI and EI occurred simultaneously and was dictated almost entirely by supply chain logistics.
Specifically, engine availability.
Yes. If a 100 horsepower UI engine arrived on the factory floor, they built an EI. If only the 80 horsepower engines were available, they built an EI.
So they were basically winging it based on what was in the warehouse.
Pretty much. Furthermore, the lines blurred significantly. Many airframes that began production as EIs were eventually completed as EI, or they were upgraded to the EI standard later when they returned to the factory for overhauls.
Which brings us to the most prolific and defining variant of the series, the Fokker EI. With 249 units built, this was the aircraft that truly cemented the legacy of the Eindecker.
The E.III refined all the preceding structural compromises. It retained the 100 horsepower Oberursel UI engine from the E.III, but introduced a newly designed wing.
What changed with the wing?
They slightly narrowed the chord of the wing to 1.80 meters, or approximately 71 inches. This optimized the aerodynamic efficiency for that specific power plant.
To give you a sense of what constituted top-tier fighter performance in late 1915, the numbers on the E.III are fascinating. It achieved a maximum speed of 140 kilometers per hour.
Roughly 87 miles per hour.
Its endurance was listed at 1.5 hours. It boasted a service ceiling of 3,600 meters, putting it up around 11,800 feet. And it could climb to 1,000 meters in 5 minutes.
In the context of the era, combining those performance metrics with a reliable synchronized forward-firing weapon created an apex predator.
What was the standard armament on the E.III?
Most E.III were armed with a single 7.92 millimeter Spandau machine gun, though the text mentions that a few were experimentally fitted with twin Spandaus.
And the desire for more firepower inevitably leads to the final and most extreme early variant, the Fokker EIV.
They built 49 of these.
And it seems like an attempt to push the basic monoplane airframe far beyond its structural and aerodynamic limits.
The EIV was an absolute brute of an aircraft. The airframe was slightly enlarged specifically to accommodate a massive leap in propulsion. They fitted it with a 160 horsepower Oberursel U.3.
That's double the power of the EI.
Yes, and it was a 14-cylinder twin-row rotary engine, which was actually a direct, unlicensed copy of the French Gnome double lambda.
A twin-row rotary engine swinging around the nose of an airframe with no fixed tail surfaces. The gyroscopic precession, the force that violently pulls the nose up or down when you try to turn a rotary engine aircraft, must have been practically unmanageable.
Torque and gyroscopic forces would have required immense physical strength and constant massive rudder inputs to counteract, particularly during right-hand turns.
As if the engine wasn't extreme enough, Fokker attempted a massive upgrade in armament.
They didn't just want 1 or 2 guns, they tried to fit it with 3 synchronized machine guns.
3 guns firing through the propeller arc.
The initial design intention was to standardize the EIV with an experimental triple gun installation. However, synchronizing 3 separate weapons to fire through a single propeller arc proved to be a mechanical bridge too far.
I can imagine.
The complex linkages repeatedly failed, and they were forced to abandon the concept, eventually standardizing the EIV with twin machine guns mounted above the forward fuselage.
Across all these variants, from the EI to the EIV, Fokker produced a total of 416 Eindeckers. And when these 416 aircraft hit the front lines, they fundamentally altered the psychology and the statistics of the air war.
This period became known as the Fokker Scourge.
The Fokker Scourge is a definitive epoch in aviation history. It spanned from roughly July 1915 through the early months of 1916.
During this window, the Eindecker provided the German Fliegertruppen with an undisputed qualitative edge, granting them localized air superiority over the Western Front.
The psychological toll on the Allied air crews is perfectly encapsulated by the nickname they adopted for their own aircraft. They referred to their poorly armed pusher propeller biplanes and observation machines as Fokker Fodder.
Fokker Fodder.
The sheer dread of operating obsolete technology in airspace, dominated by a dedicated hunter, must have been crushing. But what's really interesting is how the German high command initially deployed them. They didn't form massive fighter wings right away, did they?
No, the tactical doctrine had to catch up to the technology. Initially, the E.ATNs were distributed piecemeal. They were allocated in singular units, acting as attached aircraft to the standard Feldflieger Abteilung.
So a typical unit consisted of 6 two-seat reconnaissance biplanes, and they would receive just one Eindecker.
Correct. Its role was strictly defensive. It was tasked with flying escort and protecting the observation machines from Allied interlopers. The concept of the offensive fighter sweep hadn't materialized yet.
The shift from defensive escort to offensive hunter begins with the pilots themselves, starting with Kurt Wintgens.
Wintgens is a seminal figure here. Flying one of the 5 original M.5KMG production prototypes, specifically E.515, he engaged and forced down a French Morane-Saulnier L two-seat parasol monoplane near Luneville.
This was on the late afternoon of July 1st, 1915.
Yes. While officially unconfirmed, this is widely recognized as the first victory for the type. 3 days later, on July 4th, he downed another Morane parasol, also unconfirmed.
He was proving the lethal viability of the system in real time.
Precisely. And shortly thereafter, on July 15th, 1915, Wintgens secured the first officially credited victory for the Eindecker.
But while Wintgens proved the concept, the aircraft achieved true legendary status in the hands of 2 pilots operating out of Feldflieger Abteilung 62. Oswald Boelcke and Max Immelmann.
These 2 pilots essentially drafted the foundational blueprints for air combat maneuvering.
Boelcke and Immelmann are the architects of modern fighter tactics. Boelcke, flying the service test aircraft E.315, was a master tactician. He went on to score 40 total victories in his career,
with 19 of those achieved in an Eindecker, making him the highest-scoring pilot in the type. His tenure with the Eindecker lasted until his final victory in the aircraft on June 27, 1916.
And Immelmann's trajectory is equally fascinating. He was assigned the very first production EI, serial number E.1315.
Immelmann received E.1315 just before the end of July 1915. Both he and Boelcke rapidly developed their skills, with both men scoring their first EI kills in August of 1915.
And Immelmann achieved all 15 of his career victories flying the Eindecker, becoming a massive propaganda asset for the German military.
The success of these pilots created a new cultural phenomenon, the fighter ace.
And the state recognized this new brand of hero with highly specific commendations.
The metric for heroism was formally codified. The source highlights that 11 pilots managed to score 5 or more victories in the Eindecker, but there was a higher tier.
The elite of the elite.
Exactly. 5 specific men, Oswald Boelcke, Max Immelmann, Otto Parschau, Hans Burr, and Kurt Wintgens, all surpassed 8 victories while flying the Fokker.
And reaching that specific threshold of 8 kills triggered the awarding of Germany's highest military honor.
It earned them the Pour le Mérite, universally known as the Blue Max. The Eindecker was the crucible that forged these national icons.
But the dominance of a single weapon system in wartime is always finite. The Scourge had a definitive end date. How did the Allies eventually break the Eindecker's stranglehold on the airspace?
The rapid pace of wartime aerospace development ensured the Eindecker's supremacy was temporary. By early 1916, the Allies introduced their own technological counters to the front lines.
Specifically, the French deployed the Nieuport 11, and the British fielded the Airco DH.2.
These new Allied fighters possessed flight envelopes and maneuverability that the aerodynamically unstable Eindecker simply couldn't match. It effectively closed the performance gap.
And as the aircraft lost its dominance, the legendary aces who flew it began to fall. The death of Max Immelmann is particularly compelling because it remains a subject of intense forensic and historical debate.
Immelmann's death in June 1916 is a prime example of how chaotic combat reporting can obscure the truth.
He was killed when his E.III suffered a catastrophic mid-air breakup during an engagement with British Fe-2B biplanes.
But the controversy stems from the cause of that structural failure.
Because the German investigation pointed toward a failure of their own revolutionary technology.
The German perspective asserts that the Stangensteuerung synchronization gear failed during the dogfight. This mechanical failure caused Immelmann's own Spandau machine gun to fire at least 7 rounds directly into one of his propeller blades, severing it.
And the sudden, extreme gyroscopic imbalance of a rotary engine spinning a broken propeller would have induced vibrations violent enough to tear the engine mount from the airframe,
exceeding the structural limits of the steel tubing and causing the aircraft to disintegrate in flight.
The ultimate irony. The weapon that made him a hero ultimately destroyed his aircraft. But the British records present a completely different narrative.
The Allied accounts firmly credit enemy action. The British officially awarded the victory to Corporal J.H. Waller, who was manning the gun in an RFC Fe-2B, piloted by 2nd Lieutenant G.R. McCubbin.
The British maintained that Waller's defensive fire was responsible for bringing Immelmann down.
Given the total destruction of the airframe, the definitive truth of whether it was a synchronization failure or Allied marksmanship remains obscured by history.
And Kurt Wintgens, the pioneer of the Eindecker, survived the summer, but ultimately met his fate in the cockpit as well.
Wintgens transitioned to the twin-row EIV variant and continued flying it until September 25, 1916. By this time, the technological landscape had completely shifted.
He was engaged and fatally shot down by the French ace Alfred Heurteaux, who was piloting S7,
an aircraft that represented a massive generational leap over the aging Fokker monoplanes. That engagement essentially signaled the definitive close of the Eindecker era.
Given the high attrition rate and the fragile nature of these early aircraft, you would assume none survived the war. Yet, there is one original Eindecker left in the world. And the story of how it was preserved is an incredible, almost comedic intelligence blunder by the German military.
It is a remarkable historical anomaly that occurred on April 8, 1916.
A novice German pilot is ferrying a brand new Fokker E.III, serial number 21016. His flight plan dictates a route from Valenciennes to Wascall.
However, he encounters heavy haze, loses his bearings entirely, and wanders off course.
Low on fuel and desperate for a landing strip, he spots an aerodrome, touches down, and cuts the engine. Only then does he realize he has inadvertently landed at a British aerodrome east of St. Omer.
The psychological shock of that realization, recognizing the uniforms of the ground crew rushing toward your aircraft, it must have been paralyzing.
The source notes he was surrounded and forced to surrender before he could even attempt to set fire to the aircraft. He handed the British military a pristine, factory-fresh example of the exact aircraft that had been terrorizing their pilots for months.
The intelligence value of serial 21016 was astronomical. The British immediately subjected it to rigorous comparative flight testing directly against Allied fighters like the Marine Saunier N at St. Omer.
Following those initial trials, they transported it to the specialized evaluation facility at Immelmann in Wiltshire.
To dissect the metallurgy, the aerodynamic profile, and most importantly, the exact mechanics of the cam-driven synchronization gear.
And because the British captured it intact and preserved it for technical evaluation, it was saved from the scrap drives and the combat attrition that consumed every other airframe.
Today, that exact aircraft, 21016, sits in the Science Museum in London.
It is displayed stripped of its fabric covering, allowing you to see the chrome molybdenum steel skeleton that Anthony Fokker pioneered. It is the sole surviving original Eindecker in existence.
The survival of 21016 stands in stark, tragic contrast to the fate of Max Immelmann's original EI, serial E.1315.
What happened to it?
That profoundly significant historical artifact actually survived the entirety of the First World War and was preserved on public display in a museum in Dresden.
Oh, I see where this is going.
Yes, it was completely destroyed decades later during the massive Allied bombing campaigns of the Second World War.
An incredibly sobering final note for that specific airframe. So when we synthesize all this data, we trace a staggering technological arc. We started with a pre-war French racing and scouting design. Wooden architecture with robust German steel.
His engineers replaced unreliable oil pump linkages with a definitive cam-driven synchronization gear.
And that specific synthesis of material science and mechanical timing birthed the modern fighter plane. The Eindecker forced the world to abandon the concept of the unarmed observation platform, turning the sky itself into a lethal, three-dimensional battlefield.
It served as the undeniable catalyst that accelerated the entire global trajectory of military aerospace development.
To everyone listening, thank you for joining us on this deep dive. Our goal is to provide a comprehensive, rigorous exploration of these historical pivot points, and I hope this detailed analysis illuminated just how rapidly a singular technological integration can upend established military doctrines.
I want to leave you with a final analytical perspective to consider. The Stangensteuerung synchronization gear, when stripped of its mystique, was fundamentally just a mechanical timing mechanism.
Just a sequence of cams and rods.
Exactly. It was a minor tweak to the engine's rotation cycle. Yet, that seemingly mundane adjustment was the singular key that unlocked the devastating potential of the airframe, transforming a fragile vehicle into an apex weapons system.
Which is something to really think about.
Consider the vast, complex technological landscape we inhabit today. What seemingly innocuous minor technological tweaks, perhaps an algorithm currently in beta, or a subtle material science breakthrough, are being developed right now that possess that exact same disruptive potential. What small, unnoticed innovation will serve as the synchronization gear of our era, completely redefining the operational paradigms of tomorrow?